Welcome, everybody. We are super excited to be here. I get to have Madeline on the show, and she's going to try to keep me honest and on my feet today.
And give you lots of very exciting hot takes.
That's right.
It's my goal in life.
As the principal engineer who shows up and gives hot takes, that's your brand, right?
Yes, my goal is to make Khawaja roll his eye and stare at the camera.
Well, we are at the cusp of a pretty awesome event that's about to happen. Somebody's having a birthday pretty soon.
Yeah, I'm having a birthday pretty soon.
You
It's March
are.
29th.
Really?
It is.
Okay. Wow, I had no idea. But before your birthday, something else is having a birthday.
Valkey is actually having a birthday, which is on March 28th. That's why it's so easy to remember Valkey's birthday.
How did you not just delay the project for a day so you can share your birthday with it?
So the full story is, I believe March 28th was a Thursday.
Okay.
And when we wanted to announce Valkey, we wanted it to be on a good day to do a press release.
That's right.
Which was a Thursday. Which, also I don't want to share my birthday. I want it to be my
You
birthday.
just did. Okay, disclosing it, but you don't want
I
to.
don't want to share it with someone else.
Fair enough. Fair enough. So they can celebrate Valkey's birthday and roll into your birthday.
Exactly.
Essentially. Okay.
There's actually I'm going to go off tangent, off script, and talk about. So I was at a conference last year called Monkey Craw, which is a artisanal conference in London, and they told me that they were going to have a celebration for Valkey's birthday, and I knew what was going to happen. They were going to bring in cupcakes, and they're going to have the little Valkey logo on it. And then what actually happened is they all started singing "Happy Birthday" to me, but like the entire audience, as someone walked down the aisle with a cake.
So were they celebrating your birthday or Valkey's?
They were selling both.
Wow. All right.
We can cut that story out, but I think it's really funny.
I think it's a great story. We're not gonna cut stories, we're only gonna cut cake. As Valkey turns 2, I'm all about being able to spin things, right? Like you gotta always find the silver lining. If Valkey cannot turn into a 2-year-old without a mascot, I think Valkey needs a mascot. What do you think it should be?
So, I don't know if you know about the history of why it's called Valkey, but the original naming inception came from Valkyrie DB. And it got shortened to Valkey because no one could spell Valkyrie. But SEO also doesn't know what Valkey is. It thinks it's
Google
Valley.
still thinks it's Valley.
It still thinks it's Valley. But that's why we always thought our mascot would be a Valkyrie. They're fighting the good fight.
Yeah. Yeah, but like, how many people really know Valkyrie? Like, your mascot's got to be a cute animal that everybody could kind of relate to, I think.
Are you going to propose a squirrel?
No, that one is taken. Please stay away from the squirrel. Sam, the serverless application module in AWS, also has a squirrel for some reason. But I actually gave this a lot of thought last night.
Okay.
If Valkey had a mascot, what should it be? And I think it should be an octopus.
Isn't there another big tech project that has an octopus? The little Octocat from GitHub?
Yeah, but like, we can have an octopus. It's more important why it should be an octopus.
Okay, say more. Why should it be an octopus?
So, did you know octopus have a brain in each of their limbs?
I did actually know that.
Yeah. And each one of them can move about independently. And especially, we should have announced it with Valkey 8. The octopus limbs with their own brains, they're like IO threads. You still need the central brain, but the limbs can individually and completely independently do things.
That's true. But you can also have more or less than 8 threads.
That's a good point, but it's a good number.
8 is a round number. It is a power of 2. It is the number of bits in a byte.
Yeah. But you're right. It's hard to find octopi or octopuses. Octopus with
I think it's octopi.
16 legs.
They would in fact not be octopi because the prefix oct. What would they be? It'd be like, I think it's decahexapie?
Decahexapie, yeah, like 10 plus 6.
Yeah, I believe that would be the correct.
Yeah. Or if it had 12, it'd be like a dodeca. Dodecapod.
Dodecapod, that's correct.
All right. Well, we'll keep debating what it should be. I still think it
get
should
in the
be
comments.
Yeah. We want to
We
know,
want
as
to know
Rain
what
would put
you
it.
think. We have questions. And we
Yes,
want your answers.
that's right. That's right. But Valky's going to turn to what has been the biggest surprise as you put Valky to, like, put yourself when you were in the middle of thinking about making this big change for the world and releasing Valky as this big community project. What's different in the most surprising way between then and what you see now?
I think the biggest difference is we didn't really know if Valkey was going to be successful. It was basically a collection of a couple of developers who were working on Redis, and we were really hopeful that, we could kind of keep doing this development effort. And it's really awesome how many more contributors and companies have sort of gone on board. We saw a really big step function, especially in the last 6 months or so, of companies like Momentum get more involved in the project. And it's been really exciting. The number of net new contributors we've seen to the project has been growing consistently. We've seen recently companies like Freshworks get a little bit involved. We've seen Apple start contributing individual features. And I think people really believe that the project is here for the long haul now. And I think that's exciting. So that's what I would say.
Okay. Just the level of engagement from, so many open source projects have just one company behind them. And oftentimes when that happens, that company has perverse incentive to not let that project get too fast because then it sells less hardware and they make less money.
Yeah, that's true. It's a well-known thing. It's called single vendor open source projects. And that's why we're trying to be community driven.
I didn't even know that was a term.
It is a term, yeah. That's
Wow.
why it's something you want to avoid. There's the Linux Foundation, which the Valkey is a part of, has this whole framework to be like, hey, how do you evaluate whether or not you should lean into a project? And one of the big things they say is, if it's only one vendor that controls or contributes to the project, that's a risk. There's actually recently been some MariaDB drama that there was a component, which I believe was related to the clustering part of MariaDB, stopped getting support from someone. And so the MariaDB Foundation, which also has an enterprise offering, just dropped it. But also still has an enterprise version of it. So now the clustering system for MariaDB is only available in the enterprise system because there's no other contributor for it.
Oh, wow.
Which you could say that they're being malicious, but I will give them the benefit of the doubt. And I think they're just like, we don't want to maintain this thing.
Yeah. I mean, I think this is where there's power in the masses, right? When more and more people are using a particular project and more people are contributing to it, the likelihood of safety in that project just goes through the roof. In the history for Valkey, I mean, there was one vendor that decided to take the ball home, but they left the ballpark behind. And all the kids have gotten together, all the fired developers and all their friends are there contributing, making the play yard better than it's ever been.
Yeah.
And it's inspiring. We see a lot of contributions from people, not just on the engine side, but also on the distributed systems like cluster management, the Kubernetes operator. What is something that you really wish was already done from a technical perspective or capability perspective, but still isn't?
I think the biggest thing is we know that our clustering system, the backing storage of the data, like what actually defines the topology of a cluster, like how many shards there are, how many replicas there are to a given primary, is a little bit all over the place. We've had multiple projects. It's called cluster mode, and it's backed by something called the cluster bus. So every node in the cluster is the authoritative owner of its own state. So each primary knows which slots it owns. And we call this cluster V1, which is each node is the source of truth for its state. Now, this is annoying when you want to say delete a shard from a cluster, since a shard owns its own data. So if you remove it, now there's just no record of this information anymore. So it would be nice, instead of having a distributed source of truth, we have a single source of truth, which we sometimes call cluster V2. Which, has something maybe like, the Zookeeper has this. Kafka has implementation that's backed by Raft that keeps track of the single source of truth. And this makes a lot of distributed system problems much easier if you can just be like, hey, backing
Here's my
store of data.
topology.
Here is the topology. Because today it's like, what's the topology? And you can ask two nodes and they can give you different answers and they're both technically right. And we use, eventually consistent system for gossiping this information. So the cluster will eventually converge. It does do that correctly today. It's just a little annoying. And we keep running into issues where it would be so nice if this was just built. With durability, we've been having a lot of conversations of, how do we durably store the data that users put in a distributed system way? So the current system that Valkey has for durability is single node persistent, but doesn't work very well with replicas after failovers. So we want it to be a distributed system. So even after failovers, you still have the same strong consistency guarantees around your data. And one ways we could do that is to basically say, hey, once you've committed a write to these two nodes, like write concerns, then it's durable. And that is just so much easier if you have this single source of truth that says this is the quorum of places you have to write to. But since we don't have that, we either have to build that first or do something else, like have each individual shard like own its own raft group and commit the writes to the raft group. So it just takes a lot more effort. Not a little more effort. It takes a lot more effort to actually make this work.
So an area where I've seen a lot more progress on the flip side of this is IO threads. And IO threads are finally useful, I feel, just looking at the benchmarks and running them daily on different versions of Valkey. They just keep getting better and better. And Valkey 9.0 had some major upgrades to IO threads. I want to talk a few things about that.
Yeah. I really like how Khawaja wanted to talk about IO threads and circled right back into it.
Yeah.
So Valkey...
While you were talking, I had a thread thinking about how to get back into IO threads.
Khawaja thought he asked me a question that was leading enough that would get me to where he wanted to go. It was, in fact, not leading.
I love IO threads. They're like the limbs of an octopus.
They are, in fact, yes, in a way, they are like the limbs of an octopus. And I'll be honest, what was the question? I forgot. Because it was so...
We talked about how cluster mode hasn't gotten as far as you would like it to be, and you see a lot of work ahead. IO threads, I feel, have made a lot of progress, and I wanted to kind of hear from you how IO threads have progressed since the fork.
Fair enough. So IO threads did exist when Redis was initially created. It was a very simple system. So basically there was two phases during command execution. There was a fanned out period of time where IO threads could exist and do reads and writes. Then everything collapsed together, and then you had the command execution phase. So this worked fine. You kind of got, 2x performance improvement by throwing a lot of threads at the problem. But there's a couple of, very unsatisfying parts of this system. One is that command execution is not parallel. So the IO threads are just sitting around doing nothing. And then we also found there was some affinity problems. So memory affinity. So when you read the commands in on the IO threads, that memory is read into a specific CPU, like L1 memory cache, L2 memory cache, but it's actually executed on a different one. And so you actually have a very high L2 memory cache hit latency problem as it tries to fetch all that memory to actually execute the command. So in Valkey 8, that was our first major iteration. We called it async IO threads, but it also had this command batching. So this very simple innovation is now the IO threads can run while command execution can happen. So now everything's happening in parallel. And then importantly, we also have a phase before we execute commands to actually make sure all the memory is properly prefetched into the command execution thread to make sure it's able to very quickly execute commands. Because unlike, if you're waiting for disk IO, you actually can basically tell the kernel, hey, I would like, fetch this data and let me know when it's fetched. You can't do that with memory. The CPU does that all transparently for you. So you actually have to spend a bunch of time grooming the memory to make sure that's going to execute quickly.
And this is done in 8.1, right?
This is done all in 8.
Okay.
So this is the base level that we all need to be. I don't think anything major happened in 8.1. I think we made some iterative little performance improvements. The big iteration, the next one was 9.0. So one problem with the way the system worked is that basically what happened is the main thread would tell the kernel, hey, these are the file descriptors, like the sockets, the end user connections that I want to be listening to. then it would go and tell an individual IO thread, you're now responsible for reading from this connection, this file descriptor. And so that was a message that got sent out to it. And then the IO thread would go dutifully, read this, which is the slow part, actually reading the data out, especially if it's on TLS. So it would read this data in, and then it would send a message back to the main thread being like, hey, I'm done reading. Here you go. One problem with this is when you use pipelining, we actually have a bunch of requests coming in together. And so what was happening is the structures we built, you would only read one command out and then send the request back to the main thread being like, I'm done.
And then you do it again.
The main thread would go do epoll again. It would be like, oh, look, this guy's still readable. Go read more data. And it wasn't very efficient. So we built in, one of the key innovations was we built in this improvement such that we could read multiple commands. So that's why there was a big improvement in 9.0 to do this, this pipelining improvement. So we would read multiple commands, we'd batch them all up, and then we'd execute them. We can also apply this. This is one of the things I would like us to do is we can also apply this on single-threaded operations too. We actually don't do any memory grooming for single-threaded operations. We only do it for this multi-threading. The main benefit is from the pulling of the commands from the IO thread, like the actual command arguments, into the main thread. But we can also do it for the actual the access patterns in the data itself, right? If we need to go fetch a key called foo, we can actually go and fetch that key foo, and we don't need to fetch the arguments from the command. We just need to fetch that. So there's some cool work we can still do there. So still a lot of opportunity. So now we're at 9.0, right? This is October last year. In the next release, we have actually restructured the way this message passaging system works.
Okay.
So I talked before, the main thread's like, hey, I got a request. I'm going to send it to an IO thread. It's going to process it, send a request back. What we're going to be doing, there's some problems with that. The first is the way that works, the main thread has to basically do a bunch of different waits on a bunch of different IO threads. So if there's 4 IO threads, it has to go check all these IO threads and be like, hey, are there messages from any of these? So we changed the queuing so it's now a multi-consumer, single consumer. So for those that are familiar with lock-free data structures, the very important primitive is a queue. So you're putting items on and you're pulling items off. So our previous implementation was a single producer, single consumer. So one IO thread,
each IO thread had its own queue.
Its own queue, which is efficient. But now we basically we went and found a good implementation. So now on the message passing back from the IO threads to the main thread, there's only one queue the main thread has to wait on, which is actually going to improve the CPU efficiency a lot, especially when you have a lot of IO threads.
Sounds like it'll just improve the utilization so you don't have like a particular IO thread getting load imbalanced.
So this is because we talked about something beforehand and I'm explaining something different.
Okay.
So this is on the other side. So the main thread is the one.
This IO thread's talking to the main threads. Okay.
So
thread.
Right.
Yep.
So the main thread is the one that only has to listen to one queue because all these items are coming in. It's able to get a large batch out as opposed to having to pull from each individual queue.
Okay.
So instead of having to do a bunch of different...
Coalesce.
Yes.
Okay.
So instead of doing a bunch of contentious operations on individual queues, it's just doing one. But we also talked about before that we got started is we also improved the other side of this operation, which is the actual sending out of requests. One problem we have today is, sometimes we have imbalanced IO thread usage, right? So if we have 6 IO threads, we might, we had what we called affinity. So a single client would basically be pinned to an IO thread, but it might not be sending a lot of requests. So instead, what we have is the ability to actually send an IO request to any IO thread. So any IO thread that's waiting and available can go process this request and then send it back. So those are the 2 big innovations we have. And we're seeing about, 10-ish% improvement. Not like game changing, but like awesome that it's basically free. Some of the stuff we talked about before, like, we got like 300% performance improvements. A lot of that was just by adding more cores, right? We're able to scale up vertically better. This is actually just with the same number of cores, you're about getting 10% better, which is cool. And it's an important precursor to some more work we're going to be doing in the future. So that'll definitely be in 9.1.
So when I talk to you about throughput and performance, you're always kind of downplaying it. You're like, we can do faster. We're already fast. We're going to be a little bit faster. Who cares if it's 10%? But to be fair, like those 10% are starting to add up. I think you're more excited about something that's coming out in 9.1 beyond just these IO thread improvements, I suspect.
That's true. It's a thing called memory efficiency.
Okay.
I do love. I told Khawaja a bunch of things, and I am not staying on script.
That's good. There was no script. Just for the record, now it sounds like this is a scripted conversation. For the record, the script was right before this podcast. We said, what do you want to talk about today? So you're going off the ephemeral script that was concocted 10 minutes ago.
I just want to cause chaos. So the other big thing that I'm actually quite excited about is we made a very small memory optimization for embedded values. So a typical Valkey key value is a string and a value, right? So foo and a value bar. So when you look up the foo, you can get bar back. So most people use Valkey for very small values. You can use it for larger values, but it's optimal for small values. So we had a optimization in the past, which is, hey, if the keys and values are small, let's pack them all together in a single memory block, right? And we call these embedded strings. So we have about 8 bytes of just general overhead we need to keep track of Valkey key values. And so we have those 8 bytes. And then we had a pointer to the key and a pointer to the value. So this was basically kind of at the fork days. What we realized is, well, if the key is small, we can just embed the key into this pack of memory. So instead of having an extra memory redirection, we could just pack it in. And we also theoretically did that with the value. But one of the things we had is we still had a pointer to the value kind of embedded there. So there'd basically be a pointer to the value, but the value would immediately precede the value. And the reason is actually there's some performance optimizations that the compiler can do, because it's like, oh, this is always a pointer. I can always just follow this pointer. And if the value can be of a bunch of different places, then we don't really know. The compiler can't know. The compiler always has to do a bunch of math to figure out what this pointer is and then do the jump. But, since we're doing so much performance optimizations like we've been talking about, we thought it would be worthwhile to maybe take that small performance hit and do as much as we can. Stuff like I'm trying to remember which version this is, but we started to do linking time optimizations to make sure that Valkey, the compiler, was able to optimize the assembly code as much as possible. And so now instead of having that, extra 8-byte pointer, we just can directly stick the value object and then do the math to figure out, is this a value object or is this a pointer? So 8 bytes doesn't sound like a lot. But
on every key?
On every key.
If you have lots of tiny keys, if you have tiny keys, you get a lot of them in a 60 gigabyte working set.
Yeah, and the best case is about saving about 20% memory overhead, which is great. Most users will have much bigger keys and values, but if you actually have very small keys and values, we had a customer we talked to inside ElastiCache. They're a food delivery company, and they only had, I think, 16-byte keys and 40-byte values, and so saving 8, that's 64 bytes, and saving 8 bytes off of that is like 15%. Yeah. So exciting for them. They can scale in and get better, hopefully use less memory and save money.
Or have a larger working set,
Yeah, especially for caching.
Higher cache rate.
Higher cache rate, also a good option. So those are two cool things that are, one of the bread and butter of Valkey is we do want to just make iterative foundational improvements every single release.
Kyle always says Valkey is a combination of lots of tiny little incremental improvements that compound to something big and magical.
I think that's fair.
Yeah, and I think it's absolutely fair, because you're slinging numbers like, oh, it's just 10% faster. Oh, it's just 20% more efficient. It's not a game changer, but to quote you from 2 minutes ago, but these numbers are big, and they keep repeating themselves. So the compounding effect is certainly there. Talk to me. Let's shift gears to your favorite topic. Search and AI.
Yeah, to get back on script.
That's right. Get back on the script. Performance, search, and AI. It's what's gonna sell. But in all seriousness, any improvements to search coming in Valkey 9.1?
Yeah, so that's the other big exciting thing. So one thing that's kind of cool about the Valkey project is we have the core, which is the main Valkey server, but we also have these secondary distribution model, which is what we call Valkey Bundle, which has a bunch of modules. So we have a bunch of projects around the core that are able to iterate kind of independently. And one of the things we are very excited about is something called the Valkey Search, which implemented vector similarity search last year. So the idea being you could put a hash or a JSON object in the core,
Mhm.
and then you can then create a secondary index that is a vector index, an HNSW index on top of that. And then you can do vector similarity queries on your Valkey data. So that
But you still have
was,
to generate the embedding yourself,
you
right?
do still have to generate the embedding yourself. That's something we would love if someone wants to fix that. So if you are looking for a cool project, you should go build this.
Yeah. Auto embedding in Valkey would be awesome. But
It'd be
sorry,
so cool.
keep going.
So, that was the state of the world last year. We actually announced, I think, in June. And we've been hard at work because a lot of people say, well, vector searching is great, but we'd also like to do normal searching on text fields and numeric types and tags. And so the big thing in the Valkey Search 1.2, but will all be compiled together and launched about the same time with Valkey 9.1, is basically what we're calling full text search indexes.
Wow.
So the ability to basically search on specific fields. You can do hybrid queries along with vector similarity queries. So you can say, hey, find me all of the items that are semantically similar. If you have like an e-commerce website, you'd be like, hey, find all the items that are similar to this item, but only start with the name, or always contain the word like headphones in them, So that's the main thing that we're going to be launching, and we're hoping that it's you might compare it to something like OpenSearch, which performs similar functionality. So one difference is OpenSearch is all of their indexes are asynchronous, whereas Valkeys are all kind of effectively synchronous. So once you put the data in, it's immediately queryable in the index because it's all in memory. We index and ingest very quickly. And this is because when you actually do a write query to Valkey, it will basically block responses for that specific client until the index is fully populated.
So by the time I get an acknowledgement that my put succeeded, I can be assured that the primary has indexed it.
Correct.
Okay.
The replica might not have indexed it. The replicas do their own indexing. But you can definitely do a read from the primary and it'll be available. And we also support fan outs. So Valkey has cluster mode. We talked about having multiple shards. So each shard maintains its own index. So you can basically fan out and query all of them. So you get effectively, if you have more data, you can still get the same performance. So with a typical Valkey cluster, when you scale out, you get consistent performance. You will still get the same performance, but CPU utilization, all the nodes will still increase, right? So in a traditional Valkey workload, all operations are of 1. So if you do a get, if you double the number of nodes, you'll be able to do twice as many gets. With search, if you double the number of nodes, you'll be able to search twice as much data in the same amount of time. So still a very powerful thing if you have very low latency requirements.
Is each replica generating its own index, or is the index replicated?
That is a great question I don't have an answer to, but I can get you an answer if you're curious, or we can cut this.
Yeah. I finally got to ask Madelyn a question about Valkey that she didn't know the answer to.
I know. It's
There's
one of
no
those
way I'm
things.
cutting this.
There's no way. That's true. I'm trying deeply to remember. So there's some motivations for vector similarity search to replicate the index. Because it's so expensive to figure out where it is in the hierarchical navigable small worlds structure. So I know there was a lot of conversations about replicating the index, not just the writes, but I don't know the current state of the implementation.
I think it's good. I think it's good for people. It's empowering for people to hear that you don't have to have all the answers, and
that's true.
I think it talks about your character a little bit when you're willing to just say, I don't know, instead of just making it up and hoping nobody verifies.
Yeah, I just need to hallucinate a little bit.
That's right. You're not. I'm so happy you're not an LLM.
Can I talk about AI for 1 second, about hallucinations? You mentioned AI. So Valkey recently had some CVEs, and I was trying to understand how to reproduce it. And so I was co-piloting it. I was pair programming with Copilot. And I asked it to, I was like, I think if you send these 5 instructions, it will crash. And Copilot went off and came back and it's like, yes, it does. Here's the stack trace. I'm like, cool, thank you. And I went and looked at what it did, and it injected code into the code path to cause it to crash to produce the exact stack trace that I was expecting.
You asked for a repro.
It created a repro. So that's my feelings about AI right now. I just wanted to tell that story. We can cut that if we want. But back to the actual thing. So why do we care about full text search? Why do we care about high performance vector similarity search? Semantic search specifically is used a lot in AI workloads, right? There's a lot of human language being typed around, like, what is the weather? Is semantically similar to what is the temperature outside?
Like, or how is the weather?
How is the weather?
Lexicographically, it's different, but semantically, it's the same.
Semantically, it's the same. And so being able to
cold.
exactly, right? So you want to be able to semantically search all together, but you also need to put in context too. One thing we talk a lot about with semantic search is you can't just, so the theory behind semantic search is you have a query, like we're talking about, what's the weather out, how cold is it out, those, you can serve the same response back to those users, but you have to know that those are semantically similar. But one thing you also have to do is know when something is either both not cacheable, right? If you asked an LLM, what's the temperature where I am, and I ask it the same question. This morning I was in Napa Valley, and if I had asked that question and you asked the same question while you were in Seattle, like the response it's not cacheable, it's not the same. So you need to also add additional context. So that's what these like hybrid queries are going to be really helpful for. That's why we need to merge both the semantic and the full text type capabilities, which includes things like numerics and it supports numeric fields, tags, and basically text-based fields. But it's also going to be useful just for, full text is still very useful on its own. We know a lot of folks are interested for like e-commerce type applications to be like, hey, I want to do very fast searching on e-commerce websites. So, Amazon.com would be the quintessential example of something who might be interested in this. My employer, I don't know if we mentioned that. I'm a principal engineer at Amazon. They want to be able to do queries very quickly because they want to, be able to return results quickly to end users. Something like Valkey might be useful on the front end for that.
I can totally imagine. One thing I do take an issue with is you called, lexicographical search normal queries. And I'm like, as a caching zealot, I think KV is a normal query. So it's interesting to call that normal, but
that's true.
Make mistakes.
Normal's an interesting choice, and it's probably a poor word choice. But yeah, it's a different type of query, but still a very useful type of query.
That's right. It's a more classic sense of the query before vectors became, vector searching became so common.
Yeah.
These days. I'm just happy I got you to talk about AI for a few minutes. We're gonna shoot an entire clip of just Madelyn talking about
how much I love AI.
I will say that when you watch a car race and you're watching a car, losing or winning, it has a lot more to do with the driver than the car. So, maybe the co-piloting, maybe it had more to do with your prompt than
I mean, if you want me to talk more about AI, I do have more to say about AI. One thing that's actually very interesting in the Valkey project is the quality of code contributions from people we know are basically Gen AI one-shotting PRs has gotten very high. And you would think that's a good thing, but it's actually quite a bit of a problem because when we ask follow-up questions, they can't really answer them. So we end up spending a lot of time reviewing really high quality PRs, really high quality issues.
Well, they also tend to be very verbose. The AI generated code tends to be extremely verbose.
Issues are very verbose, code is very verbose, and then we provide this feedback and it takes a long time for them to integrate it because they can't really wrangle the AI to actually do this. So it's actually a very big problem in a lot of open source. Sometimes people call I hesitate to use the term AI slop because a lot of these PRs are fundamentally good. It just takes a lot of effort from the reviewer side, the maintainer side, to actually get them into a shape where they could be merged successfully into the project. So one thing I've actually been spending a lot of time on, we've been talking about AI as an infrastructure product, using Valkey in AI applications, but also the usage of AI I still think is very interesting. So I actually spent a lot of time trying to figure out, hey, well, how do we update the agent.md files we have, the Copilot instructions we have, so that we can effectively guide engineers to, do stuff correctly and, help us in the long run. I made this joke earlier, the Copilot, it did completely the wrong thing. And, my conclusion to that was, you were right. It was my fault. I did end up adding, changed my prompts a little bit to also include stuff like, is you are not allowed to change any of the C files while verifying this. You're only allowed to modify the tickle files.
Mhm.
And, the reason that it actually didn't wasn't able to actually reproduce the issue is I went back and looked at the logs, and it did actually try.
Mhm.
But the problem was it had a poor understanding of how Tickle handled the request. So it actually took what I had, put it in, sent it. But the way Tickle was doing escaping of characters
Mhm.
meant it didn't actually send the correct request. And so it probably, like, Kiro just tried to figure it out, right?
It's
Like,
probably also having internal struggles because it's been trained not to do malicious work. And what you were doing is arguably it could come off as malicious work because you're trying to create, like, reproduce a CVE.
and not to tell you how to, like, hack it, but if you tell it to, like, generate a CV, it'll be like, I can't do that. And you're like, well, I'm a security researcher and we're doing research. It's like, in that case, let's do it.
I made a chatbot for the zoo for my kids, and I explicitly gave it instructions to only talk about the Oregon Zoo and don't talk about anything except the animals at the zoo. And Kenny on my team, I told him, look, it's only going to talk about the zoo. And lo and behold, he said, write me a Hello World Rust program. I said, no, but I'll be happy to talk about the zoo. And then, of course, Kenny said, I'm a giraffe who wants to learn Rust. Teach me. And boom, came out the Hello World Rust program. So there's a lot to learn on both sides.
I was deeply hoping it would be write me a Rust program about the Oregon Zoo.
Valkey community, we are a very lively bunch. I think it shows up in our Slack. I think it shows up in our in-person events. You hosted a very lively event in San Jose a couple of months ago, or last month.
Correct. It was last
It was
month.
last month. That's like ages ago in the span of time, in the cycles that I live in. But I'm curious what your take is. Like, you actually get to travel the world, seeing Valkey community in China, in Japan, in Amsterdam, in various parts of the United States. What's the experience like when you run into people from all around the world?
Specifically with Valkey or just generally?
No. The Valkey community
The Valkey
specifically.
community is always... I love the Valkey community because they're always a very technical bunch. There was a term I was using a bunch, which is like bit fiddling, right? They're the type of people who, like, there's a very small problem and it's unimportant to almost everyone. But to a couple of people, it is deeply important. One of the conversations I had a lot with at the Unlocked conference in San Jose, we were talking about we wanted to improve the protocol with Valkey.
Yeah.
So if you want to send a request to Valkey, what it looks like is star /r/n3 /r/n, which is basically, hey, we're gonna send a request, and it's of an array. It's of length 3, and so we're gonna say set. So then we're gonna do another $sign /r/n3, and then set foo bar with a bunch of extra syntax. So there's a lot of just it's a very human readable syntax, but it's not very efficient, right? There's a lot of extra bits. And practically speaking, this doesn't matter all too much, right? These packets are getting wrapped in TLS, getting wrapped in TCP packets. Like, we're doing checksums on a bunch of padded zeros. But in the replication stream, it does matter, right? Because we're packing a bunch of commands together in this replication stream and shipping them down. It also matters if you're doing pipelining, right? Sending a bunch of requests together. You will be actually sending multiple commands in a single packet. And if you can fit 5 commands into a packet as opposed to
breaking
4,
the packet boundary.
You're going to get better throughput. And, we conceptually knew this was a problem. I've talked about this in the past, but no, we met someone. His name was Dylan. He works for Momento. And he was so deeply passionate about this. He's like, no, these bits, they matter. We care about this. And I love hearing about that. And I also love hearing about, we talked a little bit, I talked with some engineers at Apple as well. Talked with an engineer named Yang, and she was like, we care a lot about, basically they have a lot of issues with TLS renewals, right? So they have TLS certificates. So they have a bunch of issues.
Common topic on our Slack.
Right.
Snap also brings that up often.
And we have a bunch of functionality in place. So you can manage certificates today with Valkey. And they're like, this is a pain and we don't want to do it. We want a bunch of optimizations that make our lives easier.
Yeah.
Right. And it's like, that's great. You should go submit the PRs and we'll help review them. And coincidentally enough, her PR that she submitted had a bug in the test, which is totally fine. But what was funny is we're supposed to have TLS tests run as part of our continuous integration. And they did not catch the fact that her test was broken because our continuous integration with TLS had been broken for months and we had no idea. So sort of a random tangent, but it's the type of things that is like so fun to have. And she felt, she came to me during the conference because it had just broken. She felt so bad. I'm like, no, it's great. We found a bug and we went and fixed it. There's nothing, like this. The tests are supposed to be protecting us from this, and the fact you found it's great. I'm trying to think if anyone else had any interesting comments at that conference.
We had a bunch of debates on proxy versus not proxy, or I tried to instill that debate as much as I could.
You were phrasing it a slightly different way at the conference.
To P or not to P.
Exactly.
That's beautiful. That's like almost as good as having octopus for your mascot. But the other one was a blocking protocol, right? And it's very related. I was kind of hoping you would say the lack of a proper multiplexed protocol is the thing that you find missing still, but it's okay. It's good that we have diversity of opinion.
That's what.
But I really want to stop blocking on rest, so for lots of reasons to enable proxies to allow disk lookups without blocking.
Do you know Garnet supports that?
What's that?
Do you know Garnet supports that?
It does.
Yeah.
Okay, I did not know that.
So Garnet is basically a bunch of engineers at Microsoft who asked the question, what if Redis was written in C#?
What if Redis was written in Rust? I don't know.
That's true. I made a very hot take not too long ago about how we should not rewrite in Rust, and I think I may have actually said maybe someday. I feel like that day's maybe closer than we think. But anyways, so they have a new response type, which basically says, hey, here is a nonce. Here is, basically we will give you an unblocked signal later through the asynchronous messaging that is supported today with this unique identifier plus the response. And it's supported, I believe, in the Stack Exchange client.
Wow.
So if we did want to implement without a multiplexing protocol, there is a maybe somewhat easy way to do that.
Yeah. I mean, I just want to stop, having head of line blocking.
That's true. That was their whole thing, because Garnet natively tiers information to disk. And so, yes, basically what you said, if there's something blocked on disk.
Yeah, like disk IO or a large item that's coming back, putting that together. Were you doing unlocked again?
Yes, we are doing unlocked again. So it's happening on May 7th. It's going to be at T-Mobile Arena. What are we going to be talking about? Valkey, of course. Valkey 9.1 search. We'll be talking about all the exciting stuff going on there and all the stuff we're working to build sort of moving forward.
A lot of users with real world experience, large scale production clusters, more stories.
Many users. Yes. So me and Khawaja, what we're going to do is we're going to tell you guys some of the spiciest stories we have seen while running production systems. I know Khawaja is currently the chief marketing officer of Valkey, but in a previous life, he was in fact a very important person at AWS running many production services and now runs many production services.
Causing many outages.
And
learning a lot of lessons along the way.
Yes. And I also run a company that also does run production systems. And I, in my free time, I am a principal engineer at AWS. And I do also get to see a lot of very exciting things that fail in production.
I can't wait. I can't wait to hear those stories, and I can't wait to be your anger coach and put a little more color to the stories and say things that you can't say.
It's gonna be fun.
It's gonna be a lot of fun.